Hello, Mario. In this video I'm going to take a look at compound areas. That's areas of complex shapes that involve more than one of the shapes that we've studied or looked at so far, the triangle, the square, the trapezium and what have you. So it's compound areas. So what we're going to do is take a look at some various examples. And in each of those examples we're going to calculate the area and the perimeter of the following shape. So here we are, we have a shape here, and the numbers in red are the information that I've been given, or that's been given in the question, and the magenta is stuff that's been added afterwards. We also know that these angles here are right angles, that's being a right angle in here, and using this magenta line here, I've divided the shape up into two parts. This first two rectangles, as it turns out in this instance. Now, so the first rectangle here, rectangle A, we're going to work out the area of that, and then rectangle B. So the first thing we need to do is to work out some of the additional dimensions that we may need. So we know that this one here is 2 plus 6 is 8, and that the 14, that 14 there, 8 there. So this one length here will be 14 minus 8, which equals 6. So that will also enable us later on, it'll be helpful information for when we come to determine the perimeter. So first of all, area A, it's a rectangle, base times height. In this case, as it turns out, it's actually a square, but the base 8 and obviously the height, which is perpendicular to the base of 8, so 8 times 8, 64 metres squared. Area B here is 6 by 6, again it's a square, base times height, 6 metres by 6 metres is 36 metres, and we add the total area, A plus B, is 64 metres squared plus 36 metres squared, gives us 100 metres squared. So the area of that compound shape there, 100 metres squared. For the perimeter, in this instance here, we just need to add up the distances around the outside. So here we go, 8, 14, 6, 6, 2 and 8, adding those all together, 44 metres around the perimeter of the shape. So moving right along to our next example. Here we have a sort of a lopsided shed, if you like, and first thing we've got to do is divide it up into two shapes. I've divided it up along this line here. This shape here is a trapezium, and the shape on top of that is a triangle. We've got two right angles here. That tells us that these two sides here are parallel. So they're the parallel sides of the trapezium. And this here tells us that the two right angles there, that's the height or the distance between the parallel sides. In this case is 8. And then looking at the triangle here, we've got the side here of 4 and this one here 5.70. So we've got two sides, and we don't have a height as such from a base, but we have the angle between two sides, which enables us to use the half BC sine A area for the triangle. So let's get on with our areas. The area of A, the trapezium, is half A plus B, H, so that's a half, 6 plus 5.72, that's the parallel sides, times the distance between them, or the height, which is 8. So that gives us 46, when we multiply that out, 46.88 metres squared. The area of the triangle equals a half BC sine A. half times 4 times 5.7 times the sine of 110 degrees. And we work that out on our calculator, and we will see that that gives us 10.712,49587 as it continues on, and we can round that up to 10.71 metres squared to 2 decimal places. Remembering that we will, in the calculator that I use, I will still have both of those areas stored in the calculator. So now what I'm going to do is the total area for the shape will be area A plus area B, 46.88 plus 10.71249587, and if we add all those together we will get 57.59 metres squared to 2 decimal places. So very important that you, if you can, retain the actual most accurate number on your calculator so that you can use it later on at the end for adding them together. The perimeter of that triangle, just adding up the distances around the outside, 4 plus 6 plus 8 plus 5.72 plus 5.7. So in this case going counterclockwise, 4, 6, 8, 5.72, 5.7. Adding those all together, 29.42. That will give us the perimeter or the distance around the outside of that shape. Right, now moving right along to another example. In this example here we have a curve across the top there, forming like a semicircle or half circle there with a radius of 3 metres, and I've labelled the line between them AB. So we're given the 6 and the 5. Because the circle is such like that it has to be a right angle, it can be assumed that the other side must be 5 as well, and we need to work away on that. So area A essentially is just a rectangle, base times height, so that's 5 metres times 6 metres there, which is 30 metres squared. The area of B, now it's not a full circle, so it must be a fraction of a circle, and whatever the angle is, theta over 360. I know it's a half, but I'm just going to show you how it fits in with the formula. Pi r squared. So we know that that would be a 180 degree angle, a straight line, so it would be 180 over 360 pi times 3 squared. And that comes out at 14.13716,694. Okay, so the total area, area A plus area B, is 44.13716,699, and rounding that to 2 decimal places, 44.14 metres squared, 2 decimal places. To work out the perimeter of the shape, obviously the square sides we've got there are 5 plus 5 plus 6, but we need to work out the arc length around the circular bit. So the arc length of AB, again theta over 360 pi times diameter, pi d, equals 180 over 360 pi, and the diameter would be twice the radius, which is 6, and that is 9.4247796. So to work out the perimeter, we add to that the other sides, the 565 plus 9, and so on, and that'll give us a 25.42 to 2 decimal places. That's the perimeter distance around the outside of that shape. That shape in there being like a little circle, and that in there essentially being a rectangle. So and then we can move on to another compound shape. And here we are with two shapes, in fact, one shape within the other. So what we're trying to do is work out the area of the shaded area, which is the yellow shaded area here. We've got an external shape here, which is a trapezium. We've got 2 right angles here, so that tells us that these 2 sides here must be parallel, and that the distance between them is 12. It's fairly simple trapezium, and we've got that this distance here is 13, and inside that we have got a portion of a circle, which we call a sector, and we've got an area for that. So essentially the plan is to work out the area, the total area of the outside shape, the total area of the inside shape, take the two together, and that will give us the area of the shaded portion. So the area of A is trapezium, half A plus B H, which equals a half times 13 plus 18, which is the parallel sides, half the sum of the parallel sides, times the distance between them, 12. And multiplying that all out, it gives 186 metres squared. Now area B, it's a sector, a theta over 360, pi r squared, and the angle at the centre in this case is 270. 360 minus 90 is 270. We can see that over here. We know that the angles around that would be 360. That's 90. Take that away, must be 270. And then that's pi r squared. So that's 270 over 360. And pi, and the radius is 4 squared m. 4 squared, it's in metres. So that's going to give us 37.6991184 metres squared. So the shaded area, the yellow shaded area, is area of A, 186, minus area B, 37.691184, which is retained in the calculator, and that comes out at 148.30088881569 metres squared. And we can see that that would come out at 140.30 metres squared, and what I've forgotten to do here is add in the forgotten to add in the 2dp, so I'm going to attempt to do that now and see how we go, and put that in there, brackets. Oops, what's happened there is we just need that to be slightly bigger size, so just undo that, and I'll just put in there 2dp. So just pick that up as we're going along. Alright, now the perimeter, obviously just of the outside shape, very simply just picking up the distances around the outside, that would be 12 metres plus 13 metres plus 13 plus 18, which is 56 metres perimeter around the outside of the circle. So moving right along. And finally, one more example, and this is an example of a situation where perhaps we have a piece of land and it's alongside a river, and we wanted to maybe measure, or we've got a plan of it, we want to try and work out approximately what the area might be. So we've got a wavy, irregular line. So what we do in this instance is we can, with these particular ones, what we can do is divide it up into an even number of sort of small areas, and then we can say that if we draw a line, we can approximate the squiggly line or the wavy line by just drawing a line across the ends of them. So we're actually approximating the areas with a trapezium, as it turns out, because these two sides here are parallel, and obviously this is the distance between them here, so we've made that, and they're all at right angles like that, so it makes it very easy to work out these areas. Now these are the distances, or we might have scaled those, or may have measured them, but mostly scaled them. So these are the distance of each one. So what we do is for each little one of these, we use the trapezium, the area of a trapezium, which is a half the sum of the parallel sides times the distance between them. So in this case here, we've constantly got a distance between them of 10, and then the parallel sides. So here we've got 32 plus 36, half that and multiplied by 10 will give you the area there, and then we add to that half, and 36 plus 35, and that'll give you the area there, and so on and so on. And what we notice here is that this distance here, A, we use that once, but this distance here, B, is used in the first calculation and the second calculation. So B gets used twice. So that's what the idea of the yellow is here. And so that you can see that B, C, D, E, F, G and H all get used twice in the calculation of the total area, but A and I only get used the once. So then we work out each of the individual areas of the trapeziums, as I've recorded it here. We do that on our calculator, and you can check this, but you should get an area of 3,420 metres squared, which would be the area of that little piece of land. Now, this leads us on to a formula, or a sort of a very just specific formula for this case, called the trapezoidal rule or formula, that uses this particular sort of method here. And what it does is you can see that in each one we're multiplying by a half. So the half is what we call as a common factor. So we can put that outside this big square bracket. And then we just have to multiply everything A plus I, because they're only in there once, so we're adding A plus I, plus 2 brackets B, C, D, E, F, G and H, and then close the bracket, close the big bracket, and then of course the distance between them is 10, so everything gets multiplied by 10. So you can see that, hopefully you can see, if you multiply that calculation out as I've done it there, it's slightly easier than writing out the whole big thing, each one there, and resolves a lot of duplication issues and comes out to the same answer, 3420. So that's sort of a bit of an idea of the what we call the trapezoidal formula. It's slightly different to that. It goes on, so it obviously very dependent on the number of slices that you cut it up into. So obviously if you only have 5 slices, well, it's the first and the last plus twice the ordinates, or the bits in the middle, is the thing there, and it's multiplied by half the distance between them, which gives, if you multiply a half times 10, because they're both outside the bracket there. So that's just a bit of a little extra little bit there, and a continuation on this little concept that we call compound areas, or the trapezoidal rule, which you might formula that you might come across at some point in the future.